In previous videos, we learned how to solve triangles using the law of sines and the law of cosines. In this video, we're going to learn about another type of solving triangle problems. This one is called the ambiguous case. It is unfortunately the most complicated of all the cases we've seen so far, and that's because of the fact that there are different situations that can happen depending on the specific numbers you are given. Whereas before, I give you numbers, you go through the same steps, you get the same answers, no problems. Here, the steps you do are going to change depending on what the specific numbers are. Now first, let me tell you what is the ambiguous case. This is the angle side case, and maybe you can see why I'm not writing the acronym for it, but it is kind of convenient that the acronym being notable is something that can help you remember that this is the hard situation for solving triangles. So the idea is we're going to have an angle. Now, we don't know the length of this bottom side here, so it's dashed because we don't know how long it's going to be, but we do know the angle that's coming off from it. We know an angle. We know the value of the second side, so it's solid. We know how long it is. And then we know the length of the third side. Now, if this length is too small, if this second length is too small, then no matter what the angles are, you're never going to be able to reach this dashed line down here, and you're not going to be able to get an answer. So it's possible that when you're going through this problem, you are going to get a no solution situation. First off, that didn't happen before. When we had ASA or side, we were able to get an answer, no problem. This time, if that second side is too short based on the picture here, you're going to have no solution. Maybe the so-called best scenario would be you have this angle, you don't know the length of the bottom, but you have this other side, and that second side is exactly the perfect length to reach down here, making a right angle at the bottom, and in this case you are going to have exactly one solution to their problem. So that's kind of the one you'd like to have, because you like there being only a single right answer to a question, and that can happen when this second side is exactly long enough to meet the dotted line at a right angle. The third scenario is that second side is longer than it takes to make a right angle. And so what that means is instead of coming down a right angle, you can actually reach further out, forming your triangle, and you get this nice blue triangle here. However, you can also, for the same length, make this an isosceles triangle right here. You can have the same length and make a second triangle that also has the same angle side, and this would be a two solution case. And you're not going to know ahead of time going into the problem that this is a no solution case, is a one solution or a two solution case. You just are going to organically go through, solve the problem, and when you get to certain steps, based on the numbers you have there, you'll be able to see whether you can get a second solution or not. Okay, so let's see what we know about this particular example. We know the angle A is 40. So we know we have a 40-degree angle right here. We're saying this B is 31, so that means B is going to be the angle opposite to that. And then side A, which is opposite to angle 40 here, is 27. So I'm just going to draw it like this and assume that it's going to work out to form a triangle here. And then we're going to have to figure out what we actually get. So we're missing the bottom side, and we're missing these two angles inside here. So I'm going to start by finding angle B, right, this side. So I would have law of sines, sine of angle B over the opposite side 31 is sine of angle 40 over the opposite side 27. This will give me sine of B is 31 sine 40 over 27. Putting that in the calculator here, we have 31 sine of 40 divided by 27, and I get sine of b is 0.738. And if you do your sine inverse here, we get 47.6 degrees. So now we know we have 47.6 here, and we would like to find angle C now. We can do that by doing 180, because it's a triangle, minus 40 degrees minus 47.6 degrees. And we get 92.4 degrees. That's our angle C. And then we can go ahead and find our last side here by saying sine of 92.4 degrees over the side C we're looking for is equal to sine of 40 over 27. We'd have C is 27 sine 92.4 over sine 40, and we get a side length C here, 27 sine 92.4 divided by sine of 40, and we get rounds to 42.0, and that's our missing side. And here's a perfectly good triangle, and if this had been, say, an angle side angle problem from in the previous section, we'd be done. That's it. That's the only answer you'd have. But specifically when you're in angle side side, you need to say, well, we know the sine is 0.73. That's guaranteed to be true. But is there another angle that would work for this triangle that would also give me a sine of 0.338? And if you think about it, if you draw your unit circle here, there is the angle of 47.6 that gives us the right sine value, but there's also going to be an angle in quadrant 2 that would give us the same value. And so if I find the angle in quadrant 2 with the same reference angle, it would be this, 132.4 degrees. And we want to check, is it possible to draw the triangle with this new angle? So let's put down the sides that we knew here. And this time we're saying that angle B is 132.4. And the question is, would this possibly happen? Could we actually have this in our triangle? And we can check 132.4 and 40. That does actually work. You would have a missing angle of 7.6 degrees. And so there is actually going to be a second triangle here. If instead, let's just for sake of argument, say that instead of being 130, it had been 150 here. If you plug in your triangle, 150 and 40 would be 190, would be too big, it wouldn't be possible, and you wouldn't have a second triangle. But it is possible, so we now have our angle B, and once we have our angle B, then we find our angle C here, minus the known 40, minus 132.4. Let's get an angle of 7.6 degrees. And then we can do sine of 7.6 degrees over C is sine of 40 degrees over 27. And then we're going to go ahead and find the missing side here. 27 sine 7.6 divided by sine of 40. I get 5.6 here, and that would be the missing side in this case. And so this is a situation on the ambiguous case where we happen to have two different possible triangles. And if I ever ask you to solve something in the ambiguous case, I would expect to be given both of these triangles as the answer. If it happened to be there was only one solution, then you give me the one solution. If there happened to be no solution, you should show me the work, show me why there's no solution, and then say that, and you'll get the full credit for the problem. So you just play around with these, practice these. This is definitely the hardest of all of the cases of solving triangles. But if you can solve this one, you should be able to solve any of the easier ones like ASA or side-side.